So today we're going to take a look at converting between radical and exponential form for radical exponents and rational exponents. So we're going to go back to power of power rule as well when we're looking at these exponential forms. So radical and exponential form, the numerator of an exponent is an exponent, the denominator of an exponent is the root. Another name we can say that it's the power and it's the index. Kind of just depends on how you see that. But if you look at the little graphic here, so this is exponential form because it has an exponent. So the top, this is our regular exponent that we're used to applying. And then this is the root. The bottom, the denominator, is the root. So we can rewrite this in radical form where we have literally the radical and the little n here, which was our denominator, that shows what root we're taking. And the exponent is here next to our variable. We can also write it with parentheses here, and this is the power of the power rule, where it's kind of taking it outside of here. So it looks very similar, except they took the exponent here and they just put it outside of the parentheses. So this is radical form. So if it's in radical form, we can easily change it back to exponential form. If it's in exponential form, I can easily change it back to radical form. So I can kind of go back and forth, just depending on what I need to do in order to solve that problem. So with the first question here, it says, write the following as an exponential expression. So we have the radical, I can see the radical sign, so I know it's in radical form. It wants me to convert it back this way. So with this one, I just simply need to take into account, here's my exponent, here's my root, and I'm going to write my fraction. Exponent on top, root on the bottom. And that's it. I just converted it that quickly. All right, so let's take a look at one more here. So it does say simplify in this case. I'm not just going to rewrite it in exponential or radical form. It's already in exponential form. I'm going to actually apply them. So I do like to write it in radical form to do this because it's a little easier to understand exactly what it's asking you to do. You don't have to rewrite it. You can just start applying them if you want. But remember, it's 32 to the third power. And then we're going to take the fifth root of that. Okay, so that's 32 times 32 times 32, because that's the cube. And then I can even break these down. If I remember, we actually did this on an earlier video. 32 is 2 to the fifth power, because it's 2 times 2 times 2 times 2 times 2 gets me 32. So if you remember that, very convenient for this part. If you don't remember that, then hopefully this is a good reminder. So the reason I broke it into twos with a fifth root is because when I'm asking for a root, I'm saying, what number did I multiply by itself that many times to get there? Well, to get to 32, I multiplied 2 by itself 5 times. And then I did it again, and then I did it again. So for each one of those, I can take out 1. The fifth root of 2 to the fifth power is 2. The fifth root of 2 to the fifth power is 2 again, and the fifth root of 2 to the fifth power is 2 again. So every time I can group 5 of them together, I can take out 1. If I take out multiples, like I just did, I have to multiply them all together. So 2 times 2 times 2 is 8. Make sure I'm not going 2, 4, 6. I've seen students do that. It's 2 times 2 is 4, times 2 is 8. So that is radical and exponential form. I hope that helped, and I will see you on the next video.